Hey everyone, welcome back to the channel. Today we'll dive into one of the most essential pattern in cloud engineering. That's the three-tier architecture. I'm your host, Samuel, and I'll be your cloud coach for this journey. Now let's start with the basics. A three-tier architecture. A three-tier architecture, it actually splits our application into three tiers, just like the name says. The first is the presentation layer. That's actually our front end. That's what our users see. And then the second layer is the business logic layer. That's actually the backend logic, and it's responsible for backend logic and processing. And then the data tier, which is where our data lives, right? So this separation, this logical tier level separation, right? This actually makes our app more scalable individually, scaling them on their own individual tiers, and then it makes them secure by separating them from other tiers, and then it makes it more maintainable. So let me give you a three-tier diagram walkthrough. In this architecture we're looking at, let's walk through each component and see how they fit together. So first comes the presentation layer, and in that we're looking at the presentation layer having Amazon Cognito. It has Amazon S3, and it also has Amazon CloudFront. So Amazon Cognito, it actually handles user authentication. The users sign up, they log in, and Cognito manages both their logging in and their signing up, right? And then there is S3. The S3 here stores all our static website assets like HTML, like CSS, like JavaScript, and all the images. So that's basically everything in your static website. It sits here. And then there is CloudFront, which sits right before S3. It actually distributes our website globally. It's actually a caching service. It distributes all our websites globally, and it ensures that the users get fast load times irrespective of where the user is browsing our website. In other words, it ensures fast loading times for users everywhere in the world. And using S3 and CloudFront in this way is actually much cheaper than running web servers for 24 bar 7, because here we only pay for what we use, and by this our site is super resilient. Now let's talk about business logic. Under the business logic tier, we have Amazon API Gateway, and then we have AWS Lambda. Now, Amazon API Gateway, it acts as a front door for all our applications API. It actually securely exposes endpoints to the front end. And AWS Lambda here, Lambda is a serverless, you know that, and it runs our backend code without servers. So when an API call comes in, Lambda executes our logic, and if more requests comes in, right, it scales automatically and adds more resource to meet the increased capacity. And talking about Lambda, it's a real game changer for anybody who's out there and who is budget conscious. Here, we don't have to manage any servers, and we only pay when our code runs. And then there is data tier. And in data tier, we have Amazon DynamoDB. Amazon DynamoDB is a fully managed NoSQL database, and it's fast. It can scale automatically. And one of the best part here is we only pay for what we use. And this is our three-layer stack. So the user interacts with the front end, which then talks to the back end through API Gateway and Lambda, and all the data gets stored in DynamoDB. This architecture and the working model and the components used here are very simple. They are scalable individually, and as I've mentioned, they are very cost effective as well. Now let's look at the flow of the architecture, how it works. Let's see it in action. So the users, they visit our site, and CloudFront, which is right here, It serves assets from S3, and users are thrown with a login screen, and Cognito handles that authentication for us. And then the user interacts with the app. The front end calls the front end application, it calls the API gateway, and then the API gateway, it triggers the Lambda function there where our business logic sits and from where our business logic runs. And depending on whether we're calling the Lambda read or write, right? It calls the DynamoDB or makes contact with the DynamoDB, and it stores the data or it retrieves the data from DynamoDB. Now, let's look at a real world use case. Let's say Samuel is an user and he uses a photo snap application, a personal photo gallery application. Samuel wants a secure and easy way to store his photos and to view his photos and to manage his personal photos online. So he uses this app called Photo Snap, an application that's well built and all the files are stored in Amazon S3. So it's an web application built on AWS using the three-tier architecture as you see in the diagram. So let's look at the user flow. Samuel, he visits the PhotoSnap website on his laptop or on his phone, yeah, and then the website static files, right, all of them, uh, the files that are in S3, the HTML, the CSS, the JavaScript, right, all of them are delivered quickly to Samuel's browser because we have Amazon CloudFront here, which actually fetches all the files for the website. In other words, which actually fetches the website, the front end from Amazon S3. And then Samuel gets thrown an login screen through Cognito. We know Amazon Cognito handles his authentication and it checks his username and password. And once everything is verified and okay, Samuel is now securely logged in into the application. And as he navigates to the site, right, the app may request a list of albums or thumbnails, right? So his browser sends an API request to Amazon API gateway there. And after receiving this request, right, the API gateway forwards the request to Amazon or AWS Lambda function, which is behind it, and which runs the backend code to fetch all Samuel's album data. The Lambda function actually reads Samuel's photo metadata all from Amazon DynamoDB, where all the users' album and photo information are stored collectively for all the users. And now Samuel gets to see all the data that his ID is supposed to access, that his ID is supposed to view from all the data that's stored in DynamoDB. So this is the view action or the read action from Samuel's API call. Now, let's say Samuel wants to upload a photo. So he selects a photo to upload. The application sends an API request again through the API gateway to the Lambda function, which processes the upload and stores the photo in S3. So the actual photo, it gets stored in S3 for all the users. And the Lambda function there, it also updates DynamoDB with the new photos metadata. So the next time when Samuel tries to log in, this photo also gets shown to Samuel based on the metadata that's stored for Samuel's table in Amazon DynamoDB. So this three-tier architecture and the components listed here or the components used in this architecture, it works perfectly for a photo snap application because of the stability it provides. As more users like Samuel join, right, this app, it can scale automatically. It's auto scalable and it's secure as well because Cognito there ensures only Samuel can access his photos. This structure or this architecture is great filled with performance because there's CloudFront there and then S3 there. It delivers images quickly, and there is DynamoDB, which provides really fast data access. DynamoDB is very fast in its performance. And it's also an cost effective solution because all the components, or most of the components we've used here, are serverless components like Lambda, like API Gateway, and then which means that the PhotoSnap application only pays for what it really uses. We're not paying for any of the idle time. So now Samuel enjoys a seamless, secure, and fast experience managing his personal photo gallery. This architecture is great for not just that PhotoSnap application, this is great for online learning platforms as well. The scenario being, students register, they want to access the videos, take quizzes, and they want to track their progress, right? If the requirement for the application is this, then this architecture serves well for that kind of request too. So the presentation here, let's understand how it works for online learning platforms. So we have the presentation tier here. Students, they sign up and log in using Amazon Cognito. And the course materials, right? The videos, the PDF, the images, they're all stored in Amazon S3 and they are delivered via CloudFront. CloudFront is great for all those media contents. And then there is business logic tier, right? For online learning platform where, or when a student starts a quiz or submits an assignment, right? The front end calls the API gateway, which then triggers a Lambda function to grade quizzes and record the scores and update the progress. So this is our business logic for online learning platform. Talking about data tier for online learning platform, right? All user profiles, quiz results, and course progresses, they're all stored in DynamoDB for fast retrieval and updates. So all the data, it lives and it's present in Amazon DynamoDB. This architecture is great for event ticketing system as well, where the scenario is the user actually browses the events, the user purchases the ticket, and the user receives digital tickets instantaneously. So this is how it'll work for an event ticketing system. So there's a presentation layer. The user authenticates with Cognito, and then they browse event listing, all of them served from S3 and CloudFront. And then there is the business logic for event ticketing system is when a user buys a ticket, the front end calls the API gateway, which triggers a Lambda function to process the purchase. It checks the seat availability and it generates an digital ticket. And then the data tier for event ticketing system, right? The event details, the ticket inventory, the purchase history, they're all stored and managed in DynamoDB and they ensure real-time updates and availability for this event ticketing system. Not just that, this is great for personal finance tracking as well, where the user wants to track their expenses, they want to set their budget, and they want to view financial reports. If that's the scenario or use case, it works well. This architecture works well for personal finance tracking as well. Through the presentation layer, the user logs in securely through Cognito, and there's a web interface, and charts are loaded all from S3 through CloudFront. And then the business logic for personal finance tracker would be when user adds expenses or generate reports, right? The API requests go through API gateway to Lambda, which processes and categorizes the transactions. Yeah. And then the data tier for the personal finance tracker would be all the finance records, the budgets, the analytics data. They're all stored in DynamoDB, allowing the users to instantaneously see their updated financial status. So these examples here, they show how the same cloud native serverless three-tier architecture, it can be powered to use a wide variety of secure, scalable, and cost effective web applications. Well, that's it for today. You've learned how to design a scalable, secure, and budget friendly three tier architecture on AWS. Until next time, keep building and keep learning. Bye for now.